Hello everybody, my name is Hans Wolter and I work for a national DAB operator in Italy called DAB Italia. I take care of the planning and of the rollout of our national DAB network. In this presentation, I will analyze the behavior of DAB receivers in a context in which the single frequency network is not correctly respected. And this can be due a number of issues. Of course, there could be a drift in the in the modulator and the transmitter. There could be issues in propagation and some other problems. So, what happened? During a series of DAB tests made to check the correct functioning of the existing network, we have noticed important differences in the behavior of the DAB receivers when moving from a synchronized DAB reception to an out-of-sync scenario. Therefore, we decided to do some tests and we investigated 3 different scenarios. The first thing we did is we did some tests in the laboratory with a test receiver. After that, we did some tests in the field with different power settings for 2 transmitters we used in these tests. And at the end, we did measurements while driving with 2 different car radio types. So let's see what we found out when we did this short series of tests in the laboratory with a professional DAB receiver. In this context, we had a local DAB transmitter, which we could change in power settings, and we could change, of course, also the delay settings. And we had a remote DAB transmitter, which was broadcasting at a fixed delay and at a fixed power setting. The power set on the local transmitter was 5 watts, and the signal was going through a 6-cell filter and then to a dipole antenna on the top of the building in which we were doing the tests. As you can the carrier to noise ratio between the local and the remote transmitter was about 30 dB. And the measured field strength was around 91 dB microvolt. As we can see in the table, the reception has always been possible in this scenario. But as soon as the 2 different signals were getting near the end of the guard interval, the receiver started to have problems in reading the correct values for the delay, as you can see here, and for the carrier to noise ratio of the remote, of the local transmitter. In this context, it was not any more possible actually to read the carrier to noise ratio of the remote transmitter anyway. So when moving out of the guard interval, or even at the end of the guard interval, the carrier to noise ratio of the local transmitter diminished by nearly 9 dB, as you can see here, which is quite impressive. But more impressive is that reception always remained possible. Just to be more precise, this column indicates the offset of the local transmitter, and this column indicates the relative offset between the local transmitter and the remote transmitter. We went on and did field measurements with a professional DAB receiver, and in this case we mounted the professional receiver in a car, and we did the measurements while the vehicle was parked in 2 different locations. And you can see this here we got the first side. In this, these two measurements have been done in the first side, and you can see in this case we had a field strength of 74 dB microvolt, and then we moved to a different location with different shading, and you see we had a field strength of 65 dB microvolt, and the measurement of the carrier to noise ratio for both the local and the remote transmitters have changed. So we have two different scenarios in this case. Both sites where we did these measurements are about 500 meters away from the local transmitter, so from this one. And in this case, in the second case, you can see we have also changed the output power of the local transmitter. So we changed a number of factors in this case. Interesting is basically what we did is we had one measurement in which we were inside the guard interval and one measurement in which we had the two signals outside the guard interval. And as you can see in the second case, we could not read anymore the carrier to noise ratio of the local transmitter, but the reception was still possible. In the second scenario, we did three different measurements, one inside the guard interval, one at the end of the guard interval, and one outside the guard interval. And you can see also here we had issues in reading the carrier to noise ratio for the local transmitter. We got the BER popping up, but we still got a decent reception. So after having done this, we went for a drive, and at this point we decided to take two cars for a spin on a highway. We did these tests along a highway which was passing next to the local transmitter, and we did this with two different cars with two different DAB receiver implementations. Both receivers and both vehicles had demonstrated an uninterrupted DAB reception on this highway in a scenario without the local transmitter active. We applied to the local transmitter the settings of the last test we did on the field. So we had, as you can, a relative offset of 253 microseconds, which creates an out of SFN scenario, and we had a setting of 20 watt on the local transmitter. Of course, it must be clear that this local transmitter is just on a small building, so the coverage area is quite limited. So we created only a relatively small out of SFN area, of course. The outcome anyway had been very interesting because in car A we had no reception issues at all. So we drove basically from outside the coverage area of the local transmitter into the coverage area with the local transmitter, and therefore also in the out of SFN area, but we had no interruption of the reception, moving basically from outside to inside the SFN interference area and then outside again. Then we did this with another car, we call it car B. Settings were the same, and what we saw is basically that when the local transmitter was becoming predominant at signal level, the reception was interrupted. Getting very close to the transmitter allowed for a short time of reception, and then, of course, with the vanishing power of the local transmitter and with the becoming predominant again the remote transmitter, reception was interrupted until we were really getting out of the coverage area of the local transmitter. We could not do these tests with a professional DAB receiver because basically this receiver was not able to measure any kind of carrier to noise ratios or BER in movement in and out of SFN scenario. So it was not used in this test. Let's come to a short conclusion. First of all, of course, we have to see that there are significant differences in the behavior of two different car models, and this also shows that there are significant improvement margins in a number of DAB car receivers, and these are not just limited to an optimization of the antenna systems, but also to other things. What we really expect in the future is that we think that more receivers, or basically all receivers, shall cope with out of sync scenarios as well as did our car called A during the tests we did. Because of course it is very evident that this car implemented a far more efficient decoding strategy than car B, and it was basically able to lock to one signal and not being interfered by the out of sync signal. Okay, so I hope that this has been interesting. If you have any questions, please let me know. You can send me an email or contact WorldDAB for further information. And thank you very much.